start this recording. And interestingly, as soon as you get into this business of adding constructors to your classes, which is very, very typical type of activity, it's part of the work on your class. Remember, we were able to do something like this. Before, we were able to create our objects just by using, and actually let me time this. We were able to create objects simply by saying, you know, like we used to say integer x, now we say point pt3. Because of this constructor, C++ compiler tells us that, well, you can really no longer use the so-called default constructor. You really now have to add it explicitly and say, all right, let's allow them to construct objects by using no parameters. And from this standpoint, because default constructor will be called for pt3, perhaps what I should do is actually add this default constructor as member function to our implementation file, and perhaps because it takes no parameters, maybe, just maybe, I can set both of these guys to 0, right? So that would be a reasonable thing to do, right? So this time, if I did this, this is called a default constructor. Okay, so it has this special meaning because it allows us to create our objects simply by passing no parameters or making a choice to pass specific parameters to the constructor. So in this case, this constructor is involved. In those two cases, this constructor is invoked. So this is our introduction to some of this constructor business. Okay, so now we have 3 points constructed differently. We use set function, which initially we introduced as the only way to assign initial values to x's and y's inside of our points. But now we can use both of these constructors, and they both have to be declared. Okay, so this is a look and feel for constructors. So this is sort of an informal introduction to this. We have a very formal set of slides. They fall into the category of discussion about object life cycle. And it goes and talks about all the important things that go into place when the object creation is happening. So this is, again, we're going to continue this discussion next week. Today I'm going to focus just on some highlights about constructors. So highlight number 1. We do not call constructors. Once we try to create a point, which is an example of our class, the constructor is invoked for us. So in all these 3 lines, when pt3, 1, and 2 are being created right now, there is, well, this sort of like reminds us that there's probably a call to this constructor with 2 double values, because that's a perfect match for this set of parameters. But again, we're basically creating a variable that represents an object, but we sort of definitely not invoking making an explicit call into the constructor in this particular situation. Now, I will tell you this. Using this is discouraged in case of default constructors, because sometimes, because the compiler may be getting a little bit confused about the pt3, thinking that maybe it's like a declaration of a function which is named pt3, which takes no parameters, creates a point, and returns it back to the caller. All right. So the use of this is discouraged. Okay, so it's better syntax like to do it like this. It's perhaps a better choice. But in this case, when there are normal parameters, a compiler has no confusion about it. Well, those do look like normal parameters, and there is a constructor that is expecting these types of parameters, and therefore, there's no way that it could be wiring it any differently. It will make the constructor calls for us. So, generally speaking, we do not call constructors. So from this syntax right here, this fragment that shows instantiation of 3 objects calling 2 different types of constructors that we provided, perhaps this would explain why constructor does not have any return value as part of its syntax. Well, because first of all, responsibility of the constructor is to do something useful immediately after the object is allocated in memory. So immediately after it's being allocated in memory, the constructor executes. Right here we have definitions of our constructors. This one sets the x and y to 0. This one sets to the particular values passed to us by the user. So it does something useful immediately after the memory is allocated for our object. However, it cannot return anything. Why? Because look, this is what happens in the main function that is trying to instantiate objects and is trying to use particular constructors. But there is no place for a return value, right? The outcome of the constructor is to really create a variable and initialize it. So, well, okay. Well, maybe I could use syntax like this. Right? I could say pt1 equals point and then pass the parameters. And well, sort of like switching to explicit initializer syntax. And this is what Java programmers are required to do. Well, then perhaps again even here there is no way to return an integer from here, right? To say, oh, maybe it was unsuccessful, so maybe I should return like -1 to signal. In this syntax, if I use this even very explicit syntax to say, this is the way I'm going to instantiate my object, and this is the variable that should be initialized using this particular constructor, and this will be the name of it, there is absolutely no way to capture this integer. Because that's not what the constructor does. Constructor does its thing right here, and then the result of it is that this variable is created. So there's absolutely no place for this idea that constructor can return anything. And using a void in front of it would actually suggest that maybe at some point it can be changed to something else so that it may return something if we decided to change the return type to, say, an integer. So not even that is permitted, not part of the syntax. Constructors simply do not return anything back. They have no means for doing this. It just doesn't exist for constructors. And that sort of like sets the constructor apart from other member functions.